Have you ever wondered how ChatGPT actually works? Or where you should start learning about large language models? You're in the right place. I'm going to take you on a journey through the fascinating world of LLMs, from their humble beginnings to the cutting-edge technology we see today. In the next few days, we'll start with foundational concepts and gradually explore advanced techniques. Let's start with something interesting, a massive shift in how our world handles information. In the last decade, we've seen an explosion of unstructured data. Think photos, videos, emails, and social media posts. Structured data, like spreadsheets, is organized and easy to analyze. Unstructured data, like emails and videos, is messy but holds incredible insights. With the rise of mobile and internet usage, 80% of the world's data is now unstructured. Large language models, or LLMs, excel at interpreting this unstructured data, making them crucial for modern businesses. Now, here's where it gets exciting. Back in 2001, we were trying to understand language in a pretty simple way, just predicting the next word based on previous ones. Imagine trying to understand a Shakespeare play by only looking at 3 words at a time. Not very effective, right? The real breakthrough came in 2013, when researchers started thinking about words differently. Instead of treating them as isolated units, they began grouping words with similar meanings together, kind of like creating a map of language. But the real game changer? That came in 2015 with something called attention. Imagine giving each word the ability to look at and understand every other word in a sentence. And then in 2018. That's where the first large language models were created. We were learning natural language through exposure to large-scale corpora, aka the internet. We created bots that would scrape the internet and look for content, and we would just expose these models to this whole amount of data and create some very interesting tasks to have them learn how language actually works. Remember, we talked of neural networks, RNN, last week. Here is how it is used. The first serious attempt at giving computers a memory for language. Think of them like a reader who can remember what they read a few sentences ago. They work with something called LSTMs, long short-term memory networks, which mimic how our brains connect related ideas across time. RNNs come in various forms. One-to-one processes single inputs and outputs, like predicting stock prices. One-to-many generates multiple outputs from one input, such as creating a sentence from a keyword. Many-to-many handles tasks like machine translation and text summarization, where maintaining context is vital for accuracy. Here's an analogy. Think of RNNs like a translator with 2 brains. One brain, the encoder, compresses the original message into a universal language of numbers, while the other, the decoder, reconstructs it into something meaningful, maybe even a different language entirely. It's like zip compressing a file, sending it, and unzipping it on the other end. The encoder compresses input data, like an English sentence, into a dense, meaningful representation. The decoder then expands this representation into output, such as translating it into German. This approach allows models to learn relationships between words and their context. More specifically, in this example in here, we are looking at the LSTMs. So you have, for each input on each LSTM, you have an individual output, which is the current state of the LSTM, and you feed that state on each layer to keep the memory and to keep the understanding of the context going on. So the encoder does that for every word and creates the hidden representation. That's what you see in the middle. So this is just a compressed representation of your data. With the whole contextual meaning and word relationship encoded into it, you feed that to the decoder, and the decoder starts to actually expand this data in a different language. So if you train your network to compress and expand in a different language, that's what the decoder is doing. So you're forcing the network to create a relationship between the compressed version of your data and the decompressed version in a different way. We feed every step at a time on the encoder. We get a compressed representation and we decode that to a specific case, which is shown in here as the machine translation. However, RNNs had some serious limitations. They were incredibly slow. Imagine having to read a book 1 word at a time, never being able to skim or jump ahead. They can't be trained in parallel. They struggled with long texts, often forgetting important context from earlier paragraphs. They struggle with long-range dependencies, leading to context loss over lengthy texts. Sequential processing makes training slow and inefficient. Additionally, RNNs can't effectively handle the complexity and ambiguity of language, like interpreting sentences with multiple meanings. These challenges paved the way for advancements like attention mechanisms and transformers. They couldn't handle ambiguity well, like in the sentence, "The teacher taught the student with the book." But whose book was it? It's not just about the probability of each word given the previous words. What we actually need is understanding of the full context. To overcome RNN limitations, researchers developed attention mechanism, which allow models to focus on important parts of the input regardless of their position. This breakthrough was crucial for creating modern LLMs, which is capable of understanding context across entire paragraphs. This brings us to the modern era of language models, where we solve these problems with something revolutionary called attention. In our next session, we'll dive into how this mechanism transformed the field and led to the powerful language models we have today. Remember, while ChatGPT might seem like it appeared overnight, it's built on decades of research and innovation. Understanding these foundations is crucial for anyone wanting to work with or develop these technologies. Thank you and see you tomorrow.